So a module is a file containing Python definitions and statements, and the file name, as you may understand, may know, has to start with a py appended. A package is a collection of multiple modules and potentially other packages. Okay, and so the idea is that we are going to see several packages in the next weeks, and some of them are taken from the standard library. Sorry, excuse me. Some of them are taken from the standard library, and so, for example, you find here a lot of examples. Sorry. You find a lot of examples like numbers, math, fractions, random, etc. These are all packages that you can import. And there are a lot of them, and the point is to find them. And the general idea is that there is this Python package index, and you can find information about literally thousands of packages. In order to make use of a package, you write import numpy, and at that point you can access the namespace that starts with the name numpy. Numpy is an example of package, okay? And from now on, what you can do is to use the functions that are included in the module numpy. Okay, so numpy dot arcos0 is a function, arcos, which is included in numpy. If you try to import a package that does not exist, then you get an error like no module, no package name named I'm not installed. You may have submodules, which means that you can import not the entire set of definition, which is numpy, but maybe only a little part of it, such, for example, linear algebra inside numpy. At that point, you have several namespaces. You have the global namespaces that does not require any prefix to it. Then you have a numpy namespace, which you can access by saying numpy dot the name of a function. And then you have a numpy linalg namespace that you can access by specifying the entire name dot another part. Okay. You can also start to get quickly bored about writing this numpy dot linalg, etc. So there is the possibility to creating aliases. And you do it by this s function here. So you import numpy as np. And so now, from now on, you have a namespace called np, which contains all the function of numpy, and you can access it like this. Okay? np.matrix or numpy.linear algebra as LA. And so you can do LA dot eigenvector centrality, which is this particular function here. Sometimes you prefer to avoid to import a large amount of definitions inside your namespaces, inside your program. Maybe you are just interested to something very, very specific, like arcos, arcsin. Okay, so you can import this specific function by saying from numpy import them. From now on, you can use them as if they are defined inside your program. Okay, and you can compute them you can use them without problem. You can also do, but this is kindly not recommended, to import everything from a specific package. So you use the asterisk, which means really anything. Okay, and at that point, all the functions are inside your namespace. The problem of this is that sometimes you get several problems by having the same names for the same thing. So the idea is that if there is a math package that has pi and another package which has pi, that's perfectly fine, but maybe they have different meaning, different semantics, and so at that point you may want to be specific and say mat.py and mat. Or some other package.py. Okay. So to summarize, this is really it. Then later we will see how to define our packages, but not now. When you import a package or a module, what you do is to read everything which is inside the file, right? Importing at the moment when you do the import, and everything is imported inside a namespace called as the package name. Unless you use alias, at that point the namespace is the alias name. So you have to use the dot notation to access it. Or you can import specific attributes, meaning functions, values, classes, and so on. And the idea is that you select part of part of the definitions and import them in your current namespace. When you use from, you may have overlapping between your names and other names. So the last to be imported wins, but be careful because maybe you don't get what you expect because you forget about this. And this is a reminder of the old lectures of 2 years ago. We were still undecided about 2.x versus 3.x. The general idea is that if you still have to write 2.x code, you can import from the future specific functions like the print function, which was not present in Python 2.7, was a keyword and not a function, so you can actually do something like this. And you can also import, for example, the division, which means that now the division is exactly as the new Python instead of the 3.x Python instead of the version 2. Okay. Writing basic Python modules is very simple. So what you do is you just create a file with pi and then you can import it. But there is more than that. So for the moment, if you write a function and you want to reuse it somewhere else, this is what you can do. At that point, probably what you do is either import an entire package or the specific function. Okay. But we will look at this again later because there are other aspects that are not covered here. And so, to really be quick for people that are not seen this, the general idea is that you can read and write text files using specific packages or specific functions. And the idea that at that point you can read the content of a file. Normally, what we are going to see now is files which just contain text. So normally they have either a TXT extension or they are specific extension, but not, I don't know, doc files or Excel files, etc. Later we will see also how to import Excel files, and then that makes it easy to work with the more structured data. Okay, so the idea is that whenever you want to access a file, you get an handle to the file, and you get this through the open function that you find here. An handle is an object that refers to a given file. Is a mechanism to access the file, is not the file itself. Okay, and what you use is open, in which you open a specific file, and you may have additional information on how to open the file. And once you have the handle is a file object, and then you can do file.read, read the entire file, file.readLines, read the single lines as a list of strings, or read one function, one line at a time by reading read line, and you read one of them at a time. And you can also write clearly. Normally you write strings. If you want to write numbers, you have to transform them into strings, and then you can close the file as you have done. The arguments to the open functions are like this. The first is the name, so the name of the file that you want to open. It's actually a path, so it may contain slashes to mean files that are in folders, directories, and so on. The second argument is optional, which means that normally you open a file for reading. But if you want to specify it formally, you can say, you can use an R, meaning that you want to read a file, or a W, you want to write a file, an append, an A, which means that you append at the end of the file, a B, which means that the file is read in binary mode, that we are not going to use now. And you can also combine them, like read-write, which means that you are able both to read and write the file, or read append, reading and appending at the end of the file. Okay, so this is what you do. There is a file called table.csv. It is included in the directory data. You open it by reading, and then if you print the type, you see that is a very strange type which is used to represent a file, an handle to the file. And if you print it, you also add additional information, including the way you have printed it, opened it. Okay, and you also have information about the encoding, because different files may have different codings, but I'm not going through this now. It's something better to be explored in the labs. As soon as you're ready, you close the file. While you're doing this, because it is possible that while you write the file, what you write is not written on the disk. And the reason is for performance. So the idea is that whenever a file system, an operating system, receive a request for writing something on a file, it may wait a little bit to see if there is something else to write to the file, and then perform a single write operation. Okay, if you don't close the file and there are exception errors, etc., what you wrote is lost, because it's still in memory and not written to the file. If you are able to close it, then you're done and everything is on the file. Once the file has been closed, then it's done. The handle is not useful anymore, because if you try to read it, even if it was open in read-write mode, then you cannot do anything else, and you get an I/O operation, input-output operation on a file. Okay. Sometimes you can do something which is very good for writing. So you use this syntax with open data as f, which means I invoke open data. So I open a file called data in a read mode, because I've not specified read or write, and read is the default. The result of this opening is associated with the word, with the symbol f, with the variable f. Okay. From now on, in this part which is indented, I have access to the f variable. I can read lines, read the single line, write whatever. As soon as I'm finished this part, so as soon as I go, I don't know, to a command which is immediately after that, the file is automatically closed. So you have a more elegant way of opening and closing the file. The good part is that if there are errors, the files is automatically closed. Now you see, this is really simple, the various ways that you can read a file. you can read it as a unique element, so you can read the entire file and put it into memory. So if you print the contents, which is the result of this file read, then you get everything from the beginning to the end. This is good if you need to treat the file as a single string, and if you have enough memory, which means if the file is relatively small, because otherwise you cannot really import the entire file in memory. The same happens with the read lines, because you can already split it in different lines separated by /n, okay? And then if you print the lines, you see that is a list of strings, each representing a line. Please note that the /n is included in the string, okay? This makes sense again when you want to read the file all together. You want to read each line at a time. All the lines in a single operation, but the file is small enough to stay in memory. And what normally you do is something like this. You can read a single line one at a time. You can use it to, for example, skip parts that are not really interesting. So, for example, if here there is a surname, name /email, then the idea is that by reading this and throwing away, not using what I read, because you see I read line, then I read again line, what I read in the first line is lost. So in this way I can read a line and forget about it. Later I want to read all the lines and, for example, printing them until I finish. What you do is I read the line, I check it if it is empty. If it is empty, it means that the file has finished, and then you print one line at a time. And this makes sense for very large files, because you can read one line at a time, and so the files could be terabytes, but you don't need to read all of it at the same moment. The other part which could be interesting is the fact that you can use also an iterator which is associated with the file handle itself. So, for example, here I read all the lines which are included in the file with a simple for line in F, and then I print them. But I skip the first line because, remember, was just the titles of the file. I don't want to use them. Okay. Internally, Python keeps tracks of the lines that you have already been read. So once a line has been read, then you cannot read it again, unless you use other forms of accessing files, but that's another business for the moment. And this limitation affects all 4 methods. So, for example, if you try to do something like this, you read the entire file, then it's done. You have read the entire file. And then if you do something like this, in which you print the lines, it tells you nothing because there are no lines anymore, because all the lines have been read in lines, but here you are doing it on file. And so if you try something like this, nothing is printed. And this is reasonable because all the lines have been already read. Okay. You can also write, as we said, and you can have, for example, a result which has been computed in some way. In order to write it, you have to write a string. So you cannot write a result, you have to write the string which represents a result. When you have done, you close it and you have a output file. Okay. Okay, and this was the explanation that I was giving you. So before concluding, but this again will be probably seen better during the labs. Remember that you have sometimes very fancy ways of printing stuff. So for example, look at this. I have a string here which I can apply the format method which belongs to strings, and these strings contain these symbols, curly brackets containing a 0, curly brackets containing a 1, which means I will substitute these curly brackets containing 0 with the first element of which is given to format, and the second with the second element which is given to format. So if I do this, print 0 and 1 dot format spam eggs, I get spam eggs. If I invert 1 and 0, I can print eggs and spam. And so this is useful to print in a nice way, in a compact way, what you are trying to write. And there are a lot of other possibilities, like for example, this food is adjective, and you see that I put food instead of a 0 and adjective instead of a 1, and then you can write like something like food is spam, adjective is absolutely horrible, and then you get this spam is absolutely horrible. And you can also, but have a look at format, you can also do something like this, which means transform float number in a float number with a top 3 decimals, and you get something like this. Okay, and that's it. Okay.